Take a look at this loop. This loop kind of sucks. This loop also kind of sucks. Wouldn't you say? Yes. So let's do something about that. Sound fun? All right. Unfortunately, I already started, but I didn't make it very far. There we go. So let me catch you up. We want some sort of iteration construct, not using a Boolean condition. We want to make it a bit more first class than that. I like the keyword for. It's so ubiquitous, so we're going to do for each loops. We're not going to use each, though. I like in. For blank in blank, just like Rust, actually. I've written this function to get us started. I think we'll make arrays iterable for sure. It's easy because arrays are built into our language. So if this were a real language, we'd make this iterable property something you could implement in userland. If we had traits, type classes, we would do an iterable type class and make the syntactic construct of the language just make use of that type class. But we're not doing that. Everything's built in, so I think our life is a little bit easier. We can just decide what's iterable and what's not for now. And then if we ever wanted to make that generic, well, we could cross that bridge when we get there. So we'll say that arrays are iterable. And, why not say optionals are iterable? They're collections of one. So I could do for x in maybe x, and then my code will run if the optional had a value inside of it. That sounds really cool. Oh no, not you. FaceTime gestures. Well, I'll try not to give any provocative gestures. All right. Yeah, it sounds good to me. So what did we do? We have this and began to implement let me put this back where it goes. A type checking, part of the type checking phase for these for statements. So you might think, well, start with a parser, right? Let's first parse this thing. And that would be a fine place to start. And it's really nice to have something you can test. You can kind of go from red to green with testing if you start with a parsing. I wanted to start here in the type checker and sort of imagine I'd already parsed it because I wanted to think through some of the more interesting pieces of the design first. But it does have the downside that I can't really test it and run it. But what we have so far is this for statement. It's a statement in a block, but I do think that it can, well, yeah, I have it implemented as a statement, but I think we may end up making it an expression. That's part of what I'm toying with here is um, if the block inside your for returns a value, could the entire for loop return a new array if you want, like a Python for comprehension, but without backwards syntax. And this would sort of replace your, calling .map on all your collections in a functional language, or like we do in modern JavaScript, where we just map over arrays and get a new array. That's kind of what I'm thinking. So what I have here, the for statement has a binding. That's just an identifier. That's what you want to call the element, that you're iterating over. Looks like it has an iterable expr here. That's the thing to be iterated over, the container. And it's got a body expr as well. So, and then I got started a little bit in the parser as well, creating the parser version of this construct. So we have the iterable expression, the binding, and the body expr. So let's see how far we can get in, say, 30, 40 minutes on this feature. We'll go back to the parser for now. Okay. So we've gotten started here with creating our new struct, and we've added it to our enum for block statements. And, I think since I've done this, I have changed my mind. So I think what we'll do instead is we're going to make these expressions. In that way, it could be a statement, and that would fall under the lone expression. If you have a for that doesn't return anything, or you want to discard the result, then you would just use it in a statement position, like you can with any other expression. So that means we're going to remove this from here, and let me make sure my key thing is in a good spot for the rest of the time. And we'll rename this to for expert. You don't have to provide a binding. I think we're going to do the default binding of it. Some languages do this. We'll see if we like it. It just seems kind of fun, and it's really easy to do. So let's go there, body expert. So let's parse this thing. If we compile now, Rust Rover's a little mad at me because I recently kind of renamed this project a bit. Let me take care of this. Okay, we're back. All I did was rmrf the .idea directory. This is a JetBrains IDE, Rust Rover, and then open the project back up. But I didn't know how long it was going to take. Okay, so now we can compile, and we can fail to compile. Let's just comment out what we had in our typer here. We'll come back and grab it later. It's going to not go in here because this is no longer going to be a block statement. Let's go back to our parser. And since we are doing the parsing, I do think now is a great time to write an example program. So let's go ahead and do that. Let me make sure I have my topic showing here. Yeah, we're implementing for. All right. Let's go. We'll call our example program a.bfl. Let's just create it in the root. Okay. Main creates an int 0 cargo run. Program exited with code 0. I just can't find a home for this little guy. There. Okay, hello world. Let's make our classic x's. This will be an array event, which we don't have to specify. 1, 5, 9. These 4 x's. We do have to semi every expression. I mean, every statement in the language. It's a little annoying, but we do. Print int it. So this is a program that I think we would want to compile. Maybe we can wait on this more terse version, and we say for it in x's. This should be equivalent. And yeah, this looks great to me. So let's see what we can do. So I think we need a new keyword. So maybe we jump all the way to the lexer. We don't have a kind for keyword. We have a kind for each keyword. Keyword for. And we have a get repr. It looks like. And this one from stir. This is what we want. Token from stir. Keyword 4. Is keyword. You may say, that was a lot of boilerplate or a lot of places to check. We should introduce an object hierarchy and a trait for token kind and implement all of these values. But I say, no. Why? We have really, really efficient code here. It's very clear about what it does. And if we forgot to make for a keyword, we would know in due time. We could add it here. And this looks like a pretty easy function to maintain to me. So that's what I say to you. Okay. We've got a keyword 4. Do we have any new? Yes. Yeah, keyword in, unfortunately. So we'll add a few more. And did we miss any? No, I think those are all the spots. Compile here. Yeah, looks like we're compiling. Let's go back to our program for it, and then we have a block. I think that's it for new tokens. So let's go to the parser. And at what point do we want to parse these? Well, let's hope we have a parse statement function, which we do. But wait, it's not going to be a statement. It's going to be a type of expression. So parse expr, which is a bit more complicated because expressions are just more complicated than statements in this language. So let's reclaim some space. Sorry about that. This is an interesting type of expression. So let's put it in expression position in our example program so we can have our minds kind of in the right place. This is very much statement position. So val result would be here. We could use it as the right-hand side. And I would expect an array of unit here. Because, or void, but call it unit because there is one value of this type. And void kind of implies there is nothing inhabiting that type, which isn't correct. So unit. This scope returns unit because its last expression is a statement, was a function call that returns unit. Also because it's terminated with a semi. That's actually not implemented in this language, even if we did it here, the unit. So yeah, I would expect an array of unit here. It would be nice to say, like, I don't want you to make the array. So maybe we would just have one variant of this construct, maybe through a different keyword or some sigil somewhere to say this really is an imperative loop, not a functional one, not a comprehension. For in, for of, for each, do. Maybe we could use do for, that's getting really silly, but we understand, there's two different types. So instead, let's square our number. This starts to get a little bit exciting. And I would want this to infer to be of type array int. Okay, and then could we for it in squared print int All right, I like this. So to parse this expression, we're going to look for the keyword for, and we can do that really early. We're going to know this is a pretty easy expression to parse because we have a token that is unique. Like no other expression starts with for. So we can do it near the end. We can do it at the beginning. So we'll go into parse base expression. And I think we can just come in really early here. We don't want to come before open paren because open paren, this is a really important case where we're doing precedence, right? If you put an expression inside parens, you want that to evaluate first and then things to ripple out. So yeah, let's go right after that. So we can else if like this, and what's our condition? So we can just to do for expers not implemented, or just to do for expers, and let's see what we can do. Parse line 989. Okay. Did I do something grievous? Maybe down here where we added a bunch of commented out code. No, we didn't do that in parse. Just scanning through for, look, I'm looking in the margin to see what I've changed between now and when I last compiled. Figure out what in the world, oh, little, little fat finger, little fat finger action. Not yet implemented for expers. That's exciting. So we're here. Let's find our, it should be our only to do bang. Yes. All right. And what do I do? Well, we advance. So this puts us past the 4. We have second already. So we expect the next token to be an identifier or to be an expression. So if you look at our 2, remember we were saying you could skip these. And because we know an identifier is 1 token, we can actually look at the third token here for the keyword in. If this were an expression, we couldn't do this, but because if it's this construct, these 3 token kinds will be keyword for, ident, keyword in. So we can detect which case we're in by looking for that third kind, and I think we're already peeking at it here. So we can say if third dot kind is k keyword in, we'll say let binding. So if we have the in, then the second should be a binding. So let, if second kind is not an identifier, this is an error case. So we can return expected identifier between for and in keywords. Okay, so now we know that it is an ident, and the binding is going to be some self dot. We'll let characters. We'll call it the binding stir self dot token chars. So this gets us the characters referred to by this token, and then we're going to make an identifier. So let binding ident ident ID binding stir. Now I have an identifier ID. So some binding ident. Otherwise, if the third peaked keyword is not an in, and if it's this scenario, then we're going to require that the second, because this is the construct we're talking about, be an expression. We can't really do that. We can just assume then. We can just parse an expression. And then we can say, hey, expect an expression. And then next we can parse a block and say we expected a block. So it does kind of throw things off of it. So we're going to probably, I was thinking we'd handle these cases separately, or we could unify them once we had our binding or not. Because here, we're going to advance past the 4 in both cases. And then in this scenario, we'll advance yes, we can advance these two. And then we stop using our look aheads and we actually parse expression for our iteree. So we can do that. So we want to advance past the 4. And if there's a binding, then we're skipping in and our ident. Not skipping, but consuming. If there wasn't, then we are at the iterable expression. But iteree, we'll figure this out what to call it. Self.parse expression. I think it can be any expression, so we recurse here. If that fails, we fail. We expected an expression. Let block. And these parse helpers are, they're not greedy. I don't know what to say, but they will happily say, hey, it wasn't an expression. That's not a failure case. So we want to use this little transformer here. We actually have a helper. We have expect expression. And you see the type here changed from optional expression to expression. I don't think we have an expect block. We don't. So mm-hmm. 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 What's wrong? Who sees it? Why does this self look so different than this self? Ah, block, not block statement. Yeah, of course. Okay. We'll expect the block. We won't get the best error here. We'll get expected block. We won't get, hey, this needs to be a block because we're doing a for each thing. But that's okay. It's the cost of reuse, really. Um, if we want this to be purpose built for this case, then we need to write some code. We can't just reuse and expect things to be customized. Let's make a for expr. Iterable expr. That's our iteree. So now I just go ahead and rename this. If it's good enough name for the struct, it's good enough for here. Binding, optional identifier ID. That one's perfect. Body expr. Body expr block. And we have our span, which we'll build. Let's span. That's going to be the span of the for keyword, and then extended all the way through to the end of the span of the body expr. Okay, any expression can go here, including a block. Right, because wouldn't it be nice? Well, in that case, this would be legal, which is getting a little wild. I would want to require there to be some delimiter here, but let's make it a block. Let's make it a block. Okay, the location of our error, it was the problem was with the kind of second. So we'll pass in second to our token error. This is the wrong type for sure. We need to okay some, I believe. Something like this. You tracking? Now we got to implement everything that expressions need to be able to do. Get span is assignable. No. Display. My display in the AST is not nearly as rich as the display in the type checker. If this looks a little sad. That is why we're basically just punting to debug format, except for a couple of cases that we've implemented. We need a richer printout of the AST. We just don't have one just yet. So that's fine, and we should now get exhaustivity issue in the type checker. So expression of for expr infinite. So we need to box this expression. We could use into here as well rather than box new, but I like it to be explicit about what's being done. Okay, and can't var itself is mutable. Through calling ident ID, which takes mute self, even though the thing that's mutating is behind our ref cell, so we could not do that. The issue is that we have so how do we do this everywhere else? intern ident token. Okay, we have hello helper. All right, just take me back. Thank you. Self dot intern ident token. Okay, and that just takes the token. So I forgot I had a more powerful way to do this. Just give it a token, and I want an identifier ID, assuming it's an ident. Yeah. Okay. Okay. Now in the type checker, we're not handling for. That's great. Expression. Go all the way down. Literals, variables. And let's do it again. Type check for expers. Type check for 4 expers. Type check for expers. Nice. Let's display println. See if we parsed it correctly. So how do I make this prettier? Let me do the so like a there's got to be a more formatted way, right? Who remembers? Hmm. Oh well. Bear with me. So the iterable expert is a variable. Uh, yeah, right. Because it's let's pull up our program. The iterable expert is x's, so that's a variable. The binding is the identifier 45, which we can only assume is it. The body block is a block with statements. Looks like a single lone expression, which is a binary op of type multiply. And the two operands, the left-hand side to the multiply is variable 45, and the right-hand side is also variable 45. So that's x times x, so that's nice. It times it, I mean. Okay, and that's it. So I think that that's parsed correctly. We can probably say from here. It would have been nice to print that out, but at least yeah, we can feel good about parsing that. So that's great. Now it's time to do the fun part. We get to decide what this actually means and make it come alive. Okay, so if we recall, I think we commented out a bunch of code in here earlier in eval statement. Let's take that up to our to-do, put this in here, and think about what we have. Okay, renamed for expert. Binding, unwrap, or use it. It's default binding. Be fun to use something sillier. Data, too. Let's do that for fun. Okay. We should see it is not in scope when we run our program that uses it. The second for loop, and then we'll know that it's working. That it hit this case. Iterable expert. Okay, so let's evaluate the this expert and make sure it's iterable. So, yep, we make sure to borrow it, and self.item type of iterable seems to be unimplemented. But since we're hard coding things, it's great because we can just sort of write our own code to find out what the item type of an iterable is instead of having to like work through our, like type class trait, implementation. Eval expert requires a scope ID, and the expected type here, well, there's no expected type. We do expect it to be iterable, but we don't want to pass in the expected type of our expression because this is just part of our expression. It's not what we expect the entire thing to be. So yeah, I'm not sure how type hinting is going to work for these, but for now we'll just say no type hints. All right, I think we need to implement item type of iterable. I think is iterable is a good place to do this. This should only require self like this. And what was it taking? Yeah, I remember. So the idea was for this to just be, instead of is, let's just go ahead and option type ID here. So if it's none, then it's not iterable. Okay. Yeah. So we can select our falses here, none. Okay. And our trues. Some. Haha. That feels good. I think you can for each over strings, it'll be the characters. I know strings are more complicated than just characters, but we're just doing bytes. I mean, we're just doing the bytes. All right, cool. The element type BR, array, excellent, and none, and the inner type of the optional. Each of these are going to require their own implementation, so it's not going to be enough to just get the item type. We're going to have to write our own code for these. So I wonder if I bit off more than I can chew, and I should only do array at first. But for now, support them all. We can say we don't support them later when we're having to code gen the line of code that builds the expert that sets it. But okay, we got the item type. We create a scope. So the reason we create a scope is because we have a scope here, and we have binding in it that only lives in there. So we need a scope to create the variable it. The scope inherits everything outside of it, so I have access to everything above me inside the scope, but I'm also going to add things that are only local to it, and one of those is going to be this. So add child scope, and we add a variable to it. Variable is unhappy. Wish I really didn't have to use the mouse to see the error. Missing fields is mutable in owner scope. Well, mutable is false, and owner scope is the body scope ID. Okay, so now we add this variable to the scope. So we have the name, the string, right, that points to a thing of this type. And you can look it up by name in scope. Whenever anything runs inside here, it's going to have that name. It's going to look it up, say it's a variable by this name. Yes, this is its type. So that's why we can check that you're allowed to multiply here. That's how we're going to know the type of it. Cool. The body expr, which is now the body block. So we'll eval block instead. Borrow that block, scope ID, expected type. Now this is interesting. Do we know the expected type here? We want this block sometimes sometimes it'll yield values. Do we ever want to be able to have type hinting work inside this block? So what that would look like maybe is if I expected the result be an array of oh, optional. Let's do optional ints. Okay. Um, divisors. I don't know. So divisors, and that's going to equal. Then inside of here, if I said none, I wouldn't have to annotate this with a type. If we implement the hinting correctly, we could hint that this block will be of type optional int because the entire for construct is supposed to be of type array of optional int. So I think we can eventually do some hinting in here. I hope that made sense. So this is to do. We can hint to the block based on the expected type the entire for expr. We can. Is it fix me we should or to do we can? We'll go with to do we can. Even just note. Just be note we can. Okay. There's our body expression, and we have its type. And let's make our thing. So we're making a let's see. Do we have a for statement? I think something was created. Let me hop through here. Enum typed expression. Enum block statement. We don't have it. Okay. Typed expr. For expr. For expr. So this is going to be a typed for expr to distinguish it from the parsed one that's only been parsed. So we can just create it here. Obstruct. And it's going to look a lot like the parsed one. Just things are going to be a bit more filled out. So let's go to parse for expr. We can start here. These are all wrong, so this will be typed expr instead. And we're going to have our actual type, ret type or result type ID. I'm just glancing above to see an optional get result type of this entire expr. Body block is going to be type block, which maybe box. The binding's not even needed anymore. I think that's interesting. Okay. Maybe that's all we need for now. Let's implement some things. So we need to be able to know its type. Let's load up the clipboard. This is the span. Okay, and display. I may turn on Copilot. Right? This will be fun. Okay, I have a binding. I have a keyboard shortcut. Let's see. I think that was it. Hey, what do we have? 4. Yes. So we don't want to be conditional here, but we don't know what we use for a binding. We've thrown away that information. make it required because we'll show the default one if it was used. Um, for in display expert ta-da. Now on eval expert enter. I jump down to the end here. Type for expert. Let's make one. The fun part. Let's make one. Body block is body expert. Copilot's on now. Sorry, we'll make do. It's annoying. We'll turn them off. Blah, blah, blah. Body block. Apologies. Iterable expert. Binding. Which we don't need, but we'll do it. Body block, result type ID, and span. Yeah. To be more consistent here, this should actually just be 4. Sometimes Copilot helps you identify where you're being a little bit linguistically inconsistent because it suggests the more consistent thing often. Huh. Yeah, that doesn't make sense. Does anyone know why, oh, maybe Rust FMT. Yeah. Oh, man, that must have been so triggering for so many minutes. Thank you for bearing with me there. Okay, now we have this. Can we fail in CodeGen? Binding ident. Oh, I don't have Clippy running either. Or, yeah, we want, yes, external linter on the fly. So my settings got a little bit deleted. Okay. The result type of the entire expert is going to be dependent on what we iterated over. Type equal element type, item type, match self.get type item type. So if yeah, if we iterate over an optional, yeah, we'll get an optional back with the result type of the block. Block yield type. Yeah, okay, it has an expert type. If this block is an expression, the type of the expression. So what I'm saying is if we forward over an optional int and we called to string on it, then now we have an optional string. just like a calling map on the string. That's actually kind of neat. So, and if not the item type, no, not the item type, but the type of the iterable expert. Like let iteree. Yeah, it just helps me. We could probably figure this out above. No, we didn't have the block. So, um, the result type will be an optional of this. So let new optional equal. Yeah, we make an optional type with the inner type, a body block.expert type. Let new type ID add type, new optional. The result type is new type ID. For unrecognized cases, it's going to be unit. If it were an array, let new array type. Thank you, Copilot. Where the element type is the expert type of the body block. And then we still had string. Which is going to be array of char. Oh, no. It's going to be an array of. It could be a new string if your block yields a char. Let's do this. Okay. A little repetitive with this add type, do type ID deal. It's okay. Otherwise, we're unit. Are we, or are we array of unit? And then how do we know if we're building the array or not? We probably need to indicate at some point, if we're doing that, not here, in order to be able to code gen this reasonably. Okay. Otherwise, it'll be unit for now. Let's make one of those. Okay, sure. Okay, look, we're in CodeGen, and we have it handled for. I love this journey. It is not defined. What did I tell you? We have two choices to fix this. We all know what the more fun one is. Data 2, anyone? Oh. Okay. I'm going to change that back so we still get to have the dramatic change. The issue is when we evaluate our block, we're using the same scope we're in. We're not using our new scope. we're not using the body scope ID in which we added the binding. It is not defined. Now it's on the lower one at line 6. Data 2. Not yet implemented codegen for experts. All right, that's exactly what we like to see. Change that back to int. Data 2. It. Okay. Let me print the type of this thing as well. We can test our type checking. Let res maybe that's a good stopping point. Expert, and then we'll print its type. Type ID to string, expert get type. Codegen for expert for it in x's, it times it. This is all coming from our display function. This is not the source text. Of type array event. So we got array event for this entire thing. Let's change the block to be of type bool. Okay. And see if we get an array of bool. We did not get an array of bool. So our result type is failing us somewhere when we have an array. Well, something to look into next time. I think that's a good stopping point. We'll figure out what's going on with the type checker, make sure all the types look good before we move on to codegen.